So we are going to talk about the general chemical reactions in chemistry. This is important for you to know because as you're going through your chemistry, you normally write equations, and for you to be able to write proper equations and balance them, one, you need to know the radical, the valency of the different radicals. The second thing you need to know is the valency of the elements in your periodic table, and also you need to know the state symbol, which you're guided by knowing the solubility of these salts also for when you're looking at the reactants. And another thing that you need to know is whatever we're doing here today, the general equations. Now let us start. So the reaction between an acid and a metal is going to give you salt and hydrogen gas. Acid and a base gives you salt and water. Base plus metal oxide gives you salt and water. Remember, metal oxides act as if they are acidic in nature. So these two equations, we call them neutralization. So they are known as neutralization reaction. An acid and a carbonate, you get salt, carbon dioxide and water. Base plus metal, you get salt, and your base plus your metal, you get salt and water. Your metal and a non-metal gives you a salt. This also is what we refer to as what? Direct synthesis. Now we are going to look, so these are some of the general equations. Now the seventh one is, now we are going to look at decomposition reactions, so metal carbonate, when you hit a metal carbonate, the general equation is you get a metal oxide plus carbon dioxide. Now this is exemption of ammonium carbonate. So if you're hitting ammonium carbonate, if you hit ammonium carbonate, we are going to form ammonia. So you're going to form ammonia, okay? You're going to form carbon dioxide, and you're going to form steam. So I'm going to write water, but the state symbol is going to be gas because it is what? It is steam that has been generated. So that is exemption of ammonium carbonate. Other metal carbonates, you hit them to get metal oxide plus carbon dioxide. When you talk about hydrogen carbonates, so let me write H carbonate. This represents hydrogen carbonates. So when you're hitting hydrogen carbonates, what do you form? Now, when you hit hydrogen carbonates of metals which are high in the reactivity series, and these hydrogen carbonates of metals which are high in the reactivity series include what we are talking about now. When you hit a hydrogen carbonate of potassium and a hydrogen carbonate of sodium, okay? So when you hit a hydrogen carbonate of sodium and potassium, you're going to form a metal carbonate, okay? This metal carbonate, okay? You're going to form a metal carbonate plus carbon dioxide and water. Plus carbon dioxide and what? And water. So when you go to the eighth reaction, the eighth general equation, so number 8, so we are going to talk about nitrates. So when you decompose the nitrates of metals which are again high in the reactivity series, in this case it is sodium and potassium, you're going to form your metal nitrite. Remember, it is not nitrate, it is nitrite. Remember, we check the prefixes, and we say the prefixes helps us to identify the number of oxygen atoms present. So nitrites have if you see something which has a prefix of ITE, it means it has less oxygen atoms compared to something that has a prefix of ATE. Okay, higher. Now we're saying sodium and potassium nitrate, when you hit them, you form a metal nitrite plus oxygen gas. Other metals, and then another one under the nitrates, we're going to talk about silver and mercury. So when you hit nitrates of silver, the nitrates of silver and mercury, so which one is your silver here? The silver is the Ag, the chemical symbol of silver is Ag, for mercury is Hg. So when you decompose silver and mercury, the nitrates of silver and mercury, you're going to form a metal. The products are going to differ. You're going to form a metal, okay? You're going to form also, it is a nitrate, so you're going to form nitrogen 4 oxide plus oxygen, okay? Another equation under nitrates is ammonium nitrate. So when you decompose ammonium nitrate, I hope you can see down here. When you decompose ammonium nitrate, you form nitrogen 1 oxide and water. So we are going to write nitrogen 1 oxide plus what? Plus water. Now, when you talk about other metals, so we've talked about metals which are high in the reactivity series, that is sodium and potassium nitrate. You form metal nitrate plus oxygen gas. When you hit silver nitrate or mercury nitrate, you're going to form your metal plus nitrogen 4 oxide plus oxygen. Now, when you hit ammonium nitrate, you form nitrogen 1 oxide and water. Now, when you decompose these other metals, which are, in this case, we're going to talk about zinc, lead, calcium, and copper. So let me just write zinc. So I'll write here. So when you're talking about decomposing zinc, lead, copper, and calcium nitrate, if you hit them, the products that you're going to form are going to be metal oxide, nitrogen 4 oxide. Let me write here. So you're going to form your metal oxide. You form your metal oxide plus nitrogen 4 oxide plus oxygen gas. Okay? So those are the products that are formed after or during decomposition of nitrates. Now, let us talk about sulfates. So for sulfates, we are going to say, let us talk about sulfates. So the 9th general equation will be the decomposition of sulfates. Okay. So for sulfates, we say potassium. Okay, we say, so for sulfates, we say potassium, sodium, magnesium, and calcium sulfates. They are not affected by heat. Okay. Now, if they are heat, they're not affected by heat, but they are going to be affected by heat. Okay, when you hit them, what happens normally is they lose the water of crystallization, but they're not normally affected by heat. So sodium, potassium, sodium, magnesium, and calcium sulfates, we say they are not affected by heat. Okay. But if they are heat, they only do what? They only lose the water of crystallization. They only lose the water of crystallization. Okay, so we are going maybe to do one equation here. We're going to talk about hydrated sodium sulfate. So we're going to write an equation there. And we're going to see at its effect when heated. So we've said they're not affected by heat, but they only lose the water of crystallization. Now in this case, we're going to form, so here we write heat. So we are going to form sodium sulfate plus the water. Okay, now the water of crystallization. So these are the general chemical reactions that you encounter. Till next time, bye.